Various shader tricks like tessellation or parallax occlusion mapping were used in Unreal 4 to give the objects the illusion of containing millions of polygons. But with the introduction of the new Nanite system in Unreal 5, a lot of these tricks can be replaced with actual very high resolution polygon models. This tutorial is going to go into depth into how to create a high polygon nanite ready mesh from a single displacement texture, all completely inside Unreal 5 using the Unreal modeling tools. I've done another video showing some of the features and uses for the Unreal modeling tools, so if that's of interest you might want to check it out. The scene that you see in the background was quickly created to illustrate this technique and some other techniques. I plan to upload a sped up time-lapse showing the creation of this scene, so if that's something that interests you then please hit the subscribe button. Lastly, I'm not suggesting that tricks like parallax occlusion mapping are obsolete. They're still very useful for certain situations. For example, when you want to add detail to a surface that pushes inward, or detail that quickly conforms to that surface. But having the ability to quickly generate nanite ready meshes from displacements is a process that I've found helpful and thought it was worth sharing. First thing that you're going to need to do is enable the Unreal modeling tools. To do that you go to Edit, Plugins, and then search for Modeling. Basically all you need to do is enable that and then restart the editor. Once you restart the editor, you will have this extra icon which is the Unreal modeling tools. We'll come back to this shortly. In order to create a model from a displacement, we first need a displacement texture. What we're going to use for this particular tutorial is one of the Megascan's displacements. So in order to get that, what we're going to do is go to the Content tab, and then we're going to open the Quixel Bridge. The Quixel Bridge is basically a link to the Megascan's library. Obviously, if you're going to use any of this commercially, then you need to check the terms and conditions. But for the purpose of this demo, we're going to use a decal. But you'll also find lots of displacements inside surfaces as well. Anyway, so we're going to go to decals, and then we're going to search for the speed bump. If you've never used the Quixel Bridge before, then it's very easy to download things. You just basically select an asset and then click download here. If you'd like a large texture, then you need to set this to highest quality. But if you are happy with a lower resolution and save some bandwidth, then you can set to high quality or medium quality, and these will reduce the size of textures that you're downloading. It also relates to models, so the higher the quality, the more polygons will be inside the model that you download. Once you've downloaded your quality that you want, you can literally drag this icon inside the Unreal viewport. Once you release, it will start to load it into the engine. Once the asset's been loaded into Unreal, what you'll see is a sphere with the decal applied. If you don't see anything, one thing to be aware is that decals are projected onto surfaces. So if the decal isn't over a surface, then you won't see anything, it will be invisible. It's just something to bear in mind. If it's not showing up, it could be because it's not above a surface. We don't need the sphere, so I'm going to delete it. And then I'm going to open the content drawer using Control and Space. You'll see that you now have two new folders, which is one is the MS Presets, which basically stores all the master materials for the Megascan's assets. And the other is the Megascan's folder itself. Inside this is the various assets and models that you download. So we're going to go into that. What is downloaded is basically three textures and a material. You've got diffuse, a normal, and then you have this very unusual looking packed texture. I'm just going to open that packed texture and explain what this actually is and how it works. So when you're working in video games, you're always trying to save memory. Now one way to save memory is to store grayscale textures in the different channels of another texture. So for example, this texture has a red, green and blue channel. In the blue channel, we have the alpha for the decal. Green channel, we have the roughness. And then in the red channel, we have the displacement. We're going to use the red channel of this texture to displace our plane and create a 3D model. So the first thing that we want to do is add a plane for us to displace. So we're going to select the rectangle, and we're going to create a rectangle in the viewport. I'm going to then press escape to deselect that tool, and then I'm going to move this plane up just so that I can more easily see it inside the viewport. So now that I have a plane, the next thing I'm going to do is actually apply the diffuse texture to this plane so that I can see the shape of the speed bump on this plane. So I'm going to again open the content drawer, and then I'm going to drag the diffuse onto the plane. When I do this, Unreal will automatically create a quick material which has the diffuse applied to it. The reason that I apply the texture to the plane is just so that I can see where this displacement is actually going to happen. Otherwise, if we displace this whole plane, we're going to end up with a lot of wasted space where it's not actually displacing or doing anything. So the first thing I want to do now that I've got my texture on the plane is to subdivide this plane. Currently, the plane is one big polygon or two triangles, and we need a lot more triangles than that. So the next thing we need to do is subdivide this model, and the way I'm going to do that is using the Displace tool. So I'm going to click Displace. When you do that, you'll see that it's set to parallel noise and a displacement intensity of 10. Seeing as we're not actually going to displace anything for now, I'm just going to set this intensity to 0, and I'm going to change the displacement type to constant, and then I'm going to set the subdivision amount to 5. Now, I've enabled the wireframe, but it will default to being off, but you can turn it on by clicking this button here. And what you can see I've done now is I have divided this plane evenly into lots of triangles or cubes. What this will allow me to do is delete a lot of this very easily. So I'm going to accept that, and I'm going to go into the polygon try select mode, which is here, and I'm just literally going to select all of these polygons which I don't actually want. You just click and drag to select and shift and drag to deselect. So it's very quick and easy to select and deselect. So as you can see now, I've very roughly cut out all the areas which I don't want. So once I've selected those, I can basically click delete triangles here. And now you'll see what we have is a much closer matching plane to the shape of the object. I'm going to accept that. So now that we have our plane matching the shape more closely, we can actually displace this plane properly now. So now that we have our plane, we're going to use the Displace tool inside Unreal to create our mesh. The first thing you'll notice is that it's using the parallel noise displacement type. We need to change that to 2D texture map. Then what we need to do is assign our texture map in here. You can select it from the drop down list here, or if you press Control Space, you can drag it in from the content drawer. Once that's loaded, you'll see that you have a very low resolution version of the model. To make this higher res, what we first need to do is show the wireframe. That just allows us to see how much geometry we're actually going to be adding. One thing to be careful with increasing the subdivisions amount is that if you increase it too high, you could potentially crash Unreal. So I'd recommend going up slowly. I know that this can easily go up to 5 without causing any problems, so I'm just going to increase it to 5. You'll now notice that it's very difficult to see because the geometry is so dense that we're starting to not really actually see shape anymore. So I'm going to disable the wireframe now, and then I can have a look at this model. So as you can see, it's done a reasonably good job of displacing that. But one thing that is quite obvious to me is that it's obviously far too high. So in order to change the strength of the displacement, we need to go up to intensity here, and then choose a new value. For this, I think around 5 or 5.5 is a reasonable value. Now this value will change depending on the displacement texture's intensity, so it won't always be the same number. You'll need to find the right value for the object that you're trying to create. And what I'm going to do now is just quickly go through some of these other settings just so you have an idea of what they do. Obviously we've covered the wireframe, but underneath that you have disable size warning. Now what this basically does is if you try and increase your subdivisions to a really high number, Unreal will block you from being able to do that. And the reason for that is it doesn't want to cause your computer to explode because you've put in billions of polygons. So what I'd recommend doing is going through the increments until you get to the value that you think you want. But if you're struggling to get a high enough amount of subdivisions, then you need to enable this disable size warning, and then that will allow you to go beyond the limit of Unreal's subdivisions. I'm going to skip over the filter options, and the main reason for this is because it doesn't really affect planes. It's more for when you're working with displacement on curved surfaces and things like that. Obviously you know what this displacement map does. Underneath that we have the displacement value. This basically is to decide whether you're pushing the surface up, pushing the surface down, or keeping it central and pushing both up and down. So in our case we're pushing both up and down, but you can change this to be 0 if you want to push upwards only, or to 1 if you want to push downwards. Similar to the displacement intensity, this really depends on the displacement texture that you use. So tweaking this value and this value allow you to adjust various settings to get it to look the way you would like it to look. UV scale is really simple. It allows you to adjust the scale of the UVs. So if I set this to 2, for example, you'll see that now we have 2 versions of this thing on this one displaced plane. Offset's the same. It just allows you to offset UVs. So now we have the center is now offset to the middle. Apply adjustment curve is a really interesting feature. I'm just going to open the content drawer. As you'll see here, I've created this temporary adjustment curve. So if I open that up, what you'll see at the moment is it's a very straightforward thing. It basically goes from 0 to 1. And I've applied that curve into here. If I was to then adjust this by pulling it down, what you'll see happen is actually the intensity of the displacement is changing as I move this curve around. And that's like, well, why would you want to do that? Because you can just change the intensity here. But this allows for some other interesting options. For example, I could select this base one, right click, and then go to auto. And what that'll do is allow me to create a curve rather than a straight line. Now, as you'll see, this has created a very different profile to what I had before. Now it's quite a curved profile, whereas when these were linear, we had a very sort of peaked profile. So this just allows you to actually really fine-tune displacements. Of course, if it's from scan data, you probably don't want to affect it because it will be accurate to real world. But sometimes, you know, you're trying to do something and you've not got access to the exact displacement that you need, and it's not quite the right shape. This just allows you to make edits to that. You can even go into minus numbers, which basically means that it's pulling this edge down more. You can add extra points into the middle and do some very unusual and strange things, like have a crazy shape like this. I mean, you wouldn't really want to do something like this, but you know, there is potential uses for this, and it's quite an interesting feature. I'm just going to close that and then reset this. The last option is recalculate normals. Because we had a plane that had normals all pointing directly upwards, once we've displaced this with shape, if we don't recalculate the normals, then we're not going to actually see any of this shape that we've displaced. So I'm going to turn this off to show you what it actually does. You'll see that it looks very broken, and that is because normals are all pointing directly upwards, whereas the actual geometry is all different angles and shapes. In order for this to be correctly portrayed, we actually need to recalculate the normals on this model. So there's one more thing I'd like to talk about to do with this displacement tool inside Unreal 5. When I was using this tool to create this video, I ran into a bunch of problems where I was getting lots of stepping artifacts. You can just about see it now, but if I increase this a little bit higher, it'll become more apparent. So you can see, hopefully clearly now, that there's various stepping happening here. Now this is usually to do with the displacement not being high enough bit depth, which is just basically it doesn't have enough information to provide a smooth gradient, so you get the stepping problem. So initially I thought this was a problem with the texture, so I'll open up the texture and try and show you what I mean. You can clearly see that there's visible banding here, which, you know, would make sense. That's why we're getting these stepped areas inside our model. However, if you try to change the compression, which is what's causing this problem, it doesn't seem to affect the model at all. So if I go to, you know, set it to grayscale, for example, which you can see has improved the banding massively, but the model inside Unreal still exhibits the banding problem. Even if we use something like HDR, which is basically uncompressed, we still have banding inside the model. So my next thought was that maybe this texture itself didn't have enough bit depth in its original source for this to be able to provide a non-stepped model. However, I've tried the same texture inside Blender and other 3D software, and it is able to provide a model that is smooth rather than with the stepped issues in it. So I was very fortunate after doing the first video, one of the programmers at Unreal contacted me to say if I had any issues or questions that he would help out, which was fantastic. So I sent this issue over to him, and he kindly got back to us saying that they're looking into it and hopefully it'll be fixed in a future release. So for now, this is an issue that you're just going to have to live with, but hopefully in future updates of the modeling tools, this will be fixed. One thing, as I was saying before, to bear in mind though, the source content, the actual original displacement, has to be of a high enough bit depth, or you're going to get banding no matter what you do inside Unreal. Some models will be more obvious than others. With this model, because it has a lot of noise and detail in it, the actual banding in the main area isn't actually that visible, so it's not so much of a problem. But for some other more subtle models, like terrain surfaces that are really small undulations, then you're going to end up with stepping like this, which is a problem. But as I say, hopefully in the next updates of Unreal, this will be resolved, and then you won't have these issues going forward. Now, what we want to do is zoom in and have a look at this model and decide whether we merit adding any more subdivides. Let's try a 6th subdivision. Now this will take a little while for it to process, but it managed to do it well. And with Unreal's Nanite system, you can pretty much have almost unlimited geometry. So, you know, you could potentially even go up one more subdivision level if you would like, but just purely for speed of working, I think that that will probably be enough subdivisions for me, and then I will accept. So the next thing I'd like to show is how to sort of tidy this up a little. So what we're going to do is just sort of move this down to the ground plane. And the first thing you'll see is it's not very flat, and it makes it a little bit difficult to actually place because, you know, it's kind of floating and intersecting in different areas. So in order to fix some of these issues, I'm going to use the Lattice tool. Basically, you go over to the Deform tab and then select Lattice. If you've seen my previous video on how to create modular meshes, then this will be very similar. So I'm going to keep this short. Basically, I'll speed up this video and I'll come back once I've tidied this mesh up a little. So that's most of the sort of main lattice work done. Now all I want to do is just try and smooth out the lumpiness a little. You can see how here it's reasonably nicely sat on the surface, but here you've got some what used to be gaps. Now that I've stretched it down, it's created some really stretched areas, so I'm going to just fix that. Yeah, you'll notice that there's still stretching and there's probably some areas that could be moved up and down a bit more, but you know, as a rough example, that's how you would go about it. And one thing to bear in mind about displacement textures is that they can't have overhangs. So what you'll find is that any surface which is near vertical will give you lots of stretching. A good example of that is this surface here. You can see there's a lot of stretching, and that's because the actual surface itself was near vertical, and because it's projecting from a flat texture, these areas get stretched. So there's not a lot you can do about that, really. You can obviously edit in external software, or use the lattice to angle it a bit more, or try and push areas around. But depending on what you're going to use it for, that could be a problem that's not visible, and it might not be something that you actually need to fix. Anyway, so now that we've got the sort of basic model made, all we need to do is actually apply our texture. I'm going to use the material that Unreal made when I dragged on the diffuse, but I'm just going to edit it slightly so that I can get it to do what I need it to do. So I'm just going to do an incredibly simple material. So I've got my diffuse. I don't need the normal anymore because the normal's actually all inside the model's geometry. And what I'm going to do is drop in the displacement texture, and then all I'm going to do is take the roughness and put that into the roughness slot. And that's really all that I'm going to do with this material. I mean, obviously you could do a lot more, but for the purposes of demonstration, that is more than enough. And then I will apply that material to this object. So as I just showed in the video, it's really easy to create a displacement with an object like a speed bump. It's very easy to select the faces that you don't need because it's a rectangle. But what do you do when it's an object that's a lot more complicated? Like for example, this pothole. As you can see, I've not subdivided this massively just to make it run a bit faster. But what I'll do first is I'll just drop the material on so you can see what the object actually looks like. And what we want to do is remove all the areas that don't really have any texture, as we don't need those because that's going to be where the ground would be. So in order to do that, the one method I came up with was if you go to the try select tool, in here you've got like brush size, and it just allows you to select polygons. But what we're going to use is the all within angle, and then we're going to click anywhere on the model. Now what this does is it basically tries to select anything that's connected to the place where you select within the angle tolerance. So in this case, anything that's under 5 degrees different to what you selected. Obviously, as you can see, it's doing a reasonable job, but it's going to take ages to select it all. So what if we increase this to like 7? Now as you can see, it's selected every connected face that's within an angle of 7 degrees of where you selected. Now this is not bad actually, it's pretty much selected everything that we want. But you'll notice that there's a bunch of lines, and this is just where the angles are too steep. But there's a really easy and quick way to fix this. One, you can just click the grow button, which will allow each polygon to expand by 1. So there you go, now we've basically got rid of all those lines. And then we can use the shrink button to get back to our original selection. Now we can shrink more if we want to take in more of the texture, or we can grow more to make the texture less. So I'd say this isn't too bad. You'll see that there's a tiny area in the center here that we need to fix, so that's really easy to do. We'll just knock this down to a really small size, and then using the standard brush, we will use the shift and click to basically remove anything, and there you go. Once you're happy with the selection that you've got, you just basically click delete triangles, and then you're left with a decal which has nice edging, which when put on a tarmac or something like that, it'll give you a nice blend between this object and the object underneath. Whenever I'm using new tools or making tutorials, I usually come up with ideas of ways to make my workflow a little bit smoother, but sometimes there isn't quite the features there in the tools yet to do that particular workflow. What I thought would be useful is just to add those ideas to the videos, as you never know who's going to watch it, and it's useful for me to reference later on. So one idea that I thought of, and I spent a bit of time trying to find a way to use this, but I couldn't see a way to do it, and I could have just missed it. But one thing that would be useful for stuff like this is being able to use a texture to select polygons. So almost all decals come with an alpha, which is basically a black and white mask. So what would be amazing is if you could use this mask to select polygons. That would mean you wouldn't need to do something like that angle select. You would just be able to use the texture as a selection tool, which would allow you to very quickly remove the excess areas that you don't need. Having the ability to use textures for more features would be really useful, but one of the things I did notice when using the displacement tool, there isn't an option to choose which channel you want to use from your texture. It defaults to the red channel, I believe. Now this is great for Megascan decal textures, as the displacement's actually in the red channel, but when you use a Megascan surface texture, the displacement's actually in the blue channel, which means that you either need to, export it into another program and then re-import it, or do a whole bunch of things to be able to get it to work. So it'd be really useful if you could actually just choose which channel it was, red, green or blue. And this would also be useful for other areas within the tools, and it'd be great if it was just a standard feature for any texture map that you apply. You can choose which channels you want to be affecting that particular tool. Another thing I tried to do, but I ended up realizing it wasn't what it was for, was use a weight map. When I first saw this, I thought what it was going to allow you to do was use a texture map to decide where the most polygons would go. So for example, you might have a texture that is in grayscale, and then the closer you are to black or white would provide more polygons, and vice versa. In this case, I think the weight map is more about intensity. But it'd be amazing if you could use weight maps, like a texture map that is black and white, to control how many subdivisions there are in an object, or even more potentially useful would be the ability to use that in the simplify tool. So when you come to optimize a geometry, you can give it a texture that basically says, I want to keep more geometry over here and I want to remove more geometry from here. Just having that option is really great, because these sort of things are quite easy to bake from various software like Substance or Mixer or any of these other tools that allow you to generate textures based on models. So I'm just going to quickly tidy up this mesh now. There's a couple of different ways you can do it. So in order to make this easier, what I'm going to do is pull this mesh up, and then I'm going to add it in a box. I'm just going to snap that to the ground. And then press escape so that I've only got one, and then I'm going to turn my grid snap off, and I'm just going to position this so that it's basically going to cut away anything that's inside the box. So I'm just trying to get it sort of roughly in position. I don't want it to be too high because I want to be able to push it through the ground, so having it a little bit low will leave a bit of an overlap for me to be able to do that. So I'm reasonably happy with that. In order to remove the base of this mesh, what I'm going to do is first select the speed bump, and then I'm going to hold shift and select the box. Now what's going to happen is the box is going to be cut away from the speed bump. So to do that, I'm going to use the trim tool. You could use Boolean, but I find the trim tool is quite fast and it works reasonably well. And also, the main difference between the Boolean and the trim tool is the trim will make a hollow mesh, i.e. when it cuts away the surface, the underside will be deleted. Whereas if you do a Boolean, it will most likely create a solid mesh, so you'll have a bottom face. But since this object's always going to be on the ground, then I don't really need those faces underneath, so I'm just going to use a trim instead. So you just click trim. Once it's processed, you'll see something that looks like this. Now if you look underneath, you'll see that there's it's very hollow, which is exactly what I want for this particular type of object. And then all I need to do is click accept. The next thing that you can actually do, and this is optional, but I mean at the moment, if we show the wireframe, you can see there's a lot of polygons, and a lot of the actual vertices on these surfaces aren't actually doing anything, because obviously we subdivided this up evenly, whereas the detail is mainly in these cracks and in these bolts. So we can actually get rid of some of this geometry and it won't cause us any real issues. So what we can do to do that is literally go over to the simplify mesh button here. This tool takes a while, obviously, because it's actually trying to decimate basically your mesh. So you can see, it's difficult to see probably on the stream, but you can see that this has now decimated it to 50% of the polygons it was before. Now, Nanite can obviously handle like the millions of polygons that you would have in this mesh, but the issue that you might run into is more a problem with memory, because obviously the more polygons, the more memory this object is going to take up. So if the vertices aren't actually doing anything, i.e. they're flat or whatever, then doing a decimation on these things can be a good idea. The only thing you need to be careful of is that obviously you don't introduce like shading artifacts. Because you're removing polygons, you can potentially introduce shading problems. So I'm going to turn off the wireframe so I can actually have a look at the mesh and see if it's created any shading issues. Like a 50% reduction on a mesh this dense, it's probably not going to cause too many problems, but depending on how much you reduce it by, you might introduce more problems. And also you've got to remember there's all different types of simplification, like different algorithms and different ways. So you can try different, if you are finding you're getting issues with the smoothing, you can try a different version and see if that works better. You can choose whether it's a triangle count or percentage and stuff like these. I won't go into this because I'll probably cover this another time. Anyway, I think that looks as good, so I don't really see any reason why not to reduce it by 50%, so I'm going to accept that. So the last thing that we want to do is rename this mesh and put it into the appropriate folder. So all we need to do is press Control Space to open the content drawer and notice this mesh here. I'm going to open that, I'm going to check, make sure Nanite's enabled, but because it's created a new mesh, it's no longer enabled, so I need to re-enable that and click Apply. Once that's processed, all I'm going to do is click Save to save that change. Then I'm going to go back to my content browser with Control Space, and then I'm going to right click and click Rename. And then I'm going to accept that, and then I'm going to just drag and drop that into the speed bump folder. Now, one thing to be careful of, obviously putting into Megascans folders, is that there's potential that these might be renamed or deleted, so you're probably better to put this into your own folder, your own mesh folder. But purely for this demo, I'm just going to put it into the Megascans folder. And I'm just going to click Move here. Now if we go into here, what we have is all of our different materials, textures and models now. And that's basically it. We have our processed mesh that we can now place on any surface that we wish. So that's how you create a model from a displacement texture all inside Unreal. I hope you enjoyed this video and found it useful. If you have any questions, feel free to leave them below. As I mentioned at the start, I plan to release a time-lapse video showing the creation of the scene that you see on screen now. So if you'd like to see that or more tutorials, please consider subscribing. Thanks.